Hello everyone, welcome back to GDC English. We are here with another episode of our series that is Master Stroke. So for the post of MRB Pharmacist, we are having this series called Master Stroke, and today we are going to have our pharmaceutical chemistry subject, and the topic of today's class will be introduction, errors and impurities. So these are the topics from where we are going to have the questions, and we are now going to see the most important MCQs, multiple choice question from these given topics. So let's start. So we are having topics covered. What are the topics that we are going to cover in this video? We are having introduction to pharmaceutical chemistry, scopes, objectives, sources and types of errors, impurities in pharmaceuticals. So this is going to have questions of in today's video. So the first question we are having, in chloride limit test, the reagent used added for precipitation is. In limit test of chloride, what are the reagents that are added for the precipitation? So when we talk about the limit test of chloride, it is based on the principle that when Cl minus ion reacts with AgNO3 in presence of diluted HNO3, in presence of diluted nitric acid, if Cl minus is there, then we are going to have a precipitate of AgCl. That is, AgNO3 reacts with this chloride ion to form AgCl as our turbidity, white color precipitate turbidity. So we are asked, in chloride limit test, the reagent added for precipitation. What is the reagent that is added for this precipitation to be formed? So if we add AgNO3, we will be going to have this AgCl as our precipitate. So we will be adding silver nitrate. So B option will be the right answer. Let's have the explanation. Limit test of chloride is based on the chemical reaction between silver nitrate and soluble chloride in the presence of a dilute nitric acid to give opalescence of silver chloride. This opalescence is just like a non-transparent reflections of light. The opalescence produced is compared with the standard solution. If the opalescence in the sample is less than standard, it passes the test. If it is more than the standard, it fails the test. Okay. Next question we are having, in heavy metals limit test, the standard prepared by using solution of silver nitrate, lead nitrate, silver chloride, or it is hydrogen chloride. So for heavy metal limit test, the standard is basically prepared via lead nitrate. This is the lead nitrate, that is standard solution, and we compare with this lead nitrate solution. So B option will be the right answer. B will be the right answer. In limit test for heavy metals is based on the reaction of metallic impurities with hydrogen sulfide H2S. In acidic media, the reaction product will be sulfide of the respective metals. In acidic media, it is produced reddish black color with hydrogen sulfide, which is compared with standard lead nitrate solution. So lead nitrate solution, standard lead nitrate solution is used for the here. Okay, so as you all know, for the MRB Pharmacist Tamilnadu, we are also conducting a test series, and we are having a test every day at 6 p.m. If you haven't joined this test series, you can go and enroll yourself, and this test series is totally free of cost. No charges are there. For this, you have to first visit Google Play Store, and you have to download GDC classes application. Then you have a batch code in that application. When you basically enter with all your credentials, it will be asking a batch code, and you have to simply type that MRB in small cases and 25 without any space, this code, and you will be joined to the test series. You can also have the interface of the application given here. Like, this is your GDC classes Pharma Students First Choice app. You simply have to install from your Google Play Store. Then you log in with your credentials, your login ID passwords. You can maintain there, you can generate there, and further you visit this. At the bottom you will see home, batches, store, chats and profile. So click on the batches, then click on this plus button, and now you will be asked a code. You will be asked by a code, and simply you type MRB25 in a small letter and without any space, and then press OK button. You will be having this test series within 2 to 3 hours of this batch code entrance. Now, next question is, limit tests are conducted to. Limit tests are conducted to. Why you conduct limit tests? To detect the presence or absence of impurities, to quantify the impurities, to differentiate the impurities, or react with the impurities. So we are asked limit test conducts because of. So to detect the presence or absence of impurities, we have this limit test that are conducted, and in this we use Nessler cylinders, and further we compare with our test sample and the standard samples. So to detect the presence or absence of impurities, we give this limit test. Limit tests are generally carried out to determine the inorganic impurities present in compound. Limit test of a chloride is based on the reaction of a soluble chloride with silver nitrate. So this is the just chloride limit test. Same, we also conduct limit test for sulfate, for arsenic, for iron and other various metals. The citric acid is used in iron limit test. When we conduct iron limit test, there are some compounds like 𝙂𝙀𝙎𝙾 acid. Then we are also having ammonia. Then we use citric acid. So these are some compounds that are used in the limit test of iron. So for the iron limit test, what is the role of citric acid? Why you generally use this citric acid during the iron limit test? To prevent color due to sulfate, to prevent its precipitation by ammonia as a ferrous hydroxide, to prevent color due to chloride, to prevent its precipitation by chloride as a ferrous hydroxide. So the iron is generally present in the form of Fe3+, that is ferric ion. By a use of 𝙂𝙀𝙎𝙾 acid, we convert it into Fe2+, that is ferrous ion, and we also add ammonia here for the alkaline medium to make this medium alkaline. So ammonia can react with this iron Fe2+. So we use citric acid then and prevent this Fe2+ reaction with the ammonia in the form of ferrous hydroxide. So B will be the right answer. B is the right answer. Limit test of iron is based on the reaction of iron in ammonical solution with 𝙂𝙀𝙎𝙾 acid in presence of citric acid to form iron thioglycolate, which is a pale pink to keep deep reddish purple in color. Ferric ion is reduced to ferrous ion by 𝙂𝙀𝙎𝙾 acid, and the compound produced ferrous thioglycolate complex. This ferrous glycolate complex, it looks purple in color, and this color complexes are used to differentiate between the test sample and the standard samples. The limit test for arsenic heavy metal is done by using test tubes, Gung apparatus, separating funnel or Kipps apparatus. So we use Gung apparatus for our arsenic limit test. So B will be the right answer. B will be the right answer. This is a Gung apparatus. We are having a bottle fitted with cork, and there is a pipe, you can see, that goes upward, and here we are having lead acetate cotton wool plug to trap H2S gases if they are produced during this reaction. And we are also having a clamp that is having mercury chloride paper, HgCl2 paper fitted over it, and from the this bottle we are having purity substance, the substance that we are going to check the impurity of arsenic. Now the arsene gas from here goes to this mercury chloride paper, and if the mercury chloride paper is seen yellow in color, then we can identify that yes, there is presence of arsenic in our sample. Limit tests are performed in Nessler cylinders, measuring cylinders, Kipps apparatus or iodine flask. So no, it is not iodine flask, it's not Kipps apparatus, it's not measuring cylinder. We use Nessler cylinders for the limit test. Nessler cylinders are having two measuring units, like you can see here. We are having, look, this is a Nessler cylinder. Here we are having a 50, and here we are having a 100 ml units, 100 ml readings, and this is a Nessler cylinder. Arsene gas reacts with mercury chloride paper. So arsene gas, that is ASH3, it goes from the bottle via pipe to that mercury chloride paper, HgCl2 paper, and it produces a yellow color stain. Yellow color stain. So it's pink color. No, it's not blue, it's not red. Yes, it's yellow color. Mercury chloride paper reacts with this arsene gas to produce yellow color stain. D will be the right answer. D will be the right answer. Okay, and we just have seen that Gung apparatus is used during this arsenic limit test. In limit test of chlorides, turbidity is produced due to addition of. The turbidity is produced due to addition of what compound during chloride limit test? during chloride limit test? Is it KNO3? It is AgNO3, AgNO3, NaNO3, no, NH4NO3, no. So during chloride limit test, Cl minus reacts with AgNO3 to produce AgCl, and this AgCl is the precipitate, or you can say this is the compound through which we see turbidity of our compound. So right answer will be B, that is AgNO3 will be the right answer, and this AgCl is the precipitate. Which stain paper is used in the limit test of arsenic? What kind of stain paper it is used? pH paper? No, not at all. Cobalt nitrite? No. Mercury chloride? Yes, it is mercury chloride paper that we see in the gadget apparatus for the limit test of arsenic, and this mercury chloride paper is having yellow stain that is responsible because of the arsenic impurity in our sample. So C will be the right answer. Diathiazone is used in the limit test of diathiazone. So when we react lead with diphenyl thiocarbazone, we have a lead diathiazone complex. We are having a lead diathiazone complex, and this shows that there is presence of lead as an impurity in our compound. So diathiazone is used in the limit test of, it is lead, that is Pb, it is lead. No chloride. In case of chloride we used AgNO3 plus HNO3, dilute medium. In case of iron we use thioglycolic acid plus ammonia NH3 plus citric acid. And in arsenic we use gadget apparatus. So right answer is A, that is lead. Lead will be the correct answer. Limit test of lead is based upon the chemical reaction between lead and diphenyl thiocarbazone, that is also known as diathiazone, in an alkaline solution to form lead diathiazone complex, which is red in color. Diathiazone itself is green in color, and the lead diathiazone formed is violet in color, or you can say red in color. Thus the net resultant becomes red. Red since diathiazone is green in color and your formed this compound is violet in color, so net resultant of the compound is red. Alright, so for the preparation of MRB pharmacist, you can also have important study materials if you want just a single book with all the theory concepts, with all the syllabus that are asked, or you can say that are demanded for the MRB pharmacist. You can also go through these MRB pharmacist examination success kit. One of them is a theory book and the other is having objective. That is, if you have to prepare, you first try to revise all the content, prepare all the content, read out all the content, then you also go through the same content, or you can say topic wise MCQ practice 2. So for this you can visit theory book as well as the objective books for this MRB pharmacist examination kit. You can also have the online test series having 200 plus premium test and 35 test, that is mini test. You can also visit MRB pharmacist online test series in our application, and for the MRB pharmacist Tamilnadu, we are having a online courses, a crash course also running. You can go through and check out all the further details inside that application. In limit test of arsenic, lead acetate cotton wool plug is used to trap which gas? So as you have seen the gadget apparatus, we were having a, and here was the cork that was fitted here, and first there was a lead acetate cotton wool plug that goes upward with a mercury chloride paper, HgCl2 paper fitted in our clamp, HgCl2 paper, and this was our lead acetate cotton wool plug. Lead acetate dipped cotton wool plug, and this lead acetate dipped cotton wool plug is responsible to trap H2S gas, since when we react the compounds, the reaction that occurs in this bottle, it also leads to the formation of H2S gas, and that H2S gas can hamper the result, that is the stain that can give unwanted stains in that mercury chloride paper. So we use lead acetate cotton wool plug to trap that H2S gas. So yes, to trap the H2S gas, hydrogen sulfide gas, we use this lead acetate dipped cotton wool plug. Arsenic gas that goes upwards and react with the mercury chloride paper to give yellow stain. So right answer will be hydrogen sulfide. It is used to trap the lead acetate, hydrogen sulfide gas. Okay, so limit test of arsenic based on the reaction of the arsenic gas with hydrogen gas. And look. Here we are having where it is lead acetate plug or papers are used to trap hydrogen, any hydrogen sulfide which may evolve along with the arsenic gas. The limit test of iron depends upon the interaction of iron with. So iron reacts or interact with what compound? Barium sulfate reagent, diphenyl thiocarbazone. So this was related to lead. Thioglycolic acid, yes, thioglycolic acid. Mercury chloride is related to arsenic. So thioglycolic acid reacts with what we called iron, and iron is in the form of Fe3+. So Fe3+ is the form of impurity of iron in sample, and this thioglycolic acid first converts Fe3+ into Fe2+, that is in ferrous form, and this is used during the limit test of iron, that is thioglycolic acid, and also forms a thioglycolate complex. Thioglycolate complex that is purple in color. That is a purple in color. That is a ferrous glycolate complex. Ferrous glycolate complex. Other compounds that are used here are citric acid and ammonia. The lead acetate cotton wool is used in the limit test for arsenic too. Okay, I see this question is repeated to develop the color, to make the arsenic gas, to trap the H2. Okay, so to trap the H2S gas, we use lead acetate cotton wool plug. So I guess this question is repeated, but also the wordings are changed, so you can go through preparations. Okay, so the stain obtained by the reactions arsenic impurity in the form of arsenic gas with mercury chloride paper is compared with the standard stain obtained by the reactions of known quantity of arsenic in the form of arsenic gas. The sample shows yellow stain lesser intensity than the standard solution, then it passes the limit test. The closeness of a true value to observed value is called closeness of a true value to observed value. Okay, so you are performing an experiment and you are having result of 80. Okay, and the true value of that reactions was near about 82. So you are very much close to that true value. So what do you call this? Is this a precision, robustness, ruggedness, या फिर accuracy, or you can say the accuracy? So it is accuracy. It is accuracy, that yes, you are very close to the result, or you can say that the true value. So this is accuracy, that your result is so much accurate with the true value. The accuracy of any analytical procedure expresses the closeness of agreement between the value which is accepted either as a conventional true value or an accepted reference value and the value found. This is sometimes termed trueness. Accuracy is defined as the degree of exactness. So how much close your result was with your true value, that is known as accuracy. Uncalibrated balances, improperly calibrated volumetric flask or pipettes, malfunctioning instruments. What do you name such kind of errors? Are they personal error, instrumental error, additive errors, or accidental errors? So these all mentioned compounds are here. Those all things are apparatus, or you can say instrument. So these are instrumental errors. They falls under the category of instrumental errors. So B will be the right answer. B will be the right answer. Instrumental errors. These are invariably caused due to faulty and uncalibrated instruments such as pH meter, UV spectrophotometers, or potentiometers. So these all are instruments. Instruments used under inappropriate conditions. Pipette, burette, and volumetric flask may hold or deliver volumes slightly different from those indicated either from their graduation. So you can see that if there are not proper marking on your apparatus, nor proper balance proper, so these kind of errors comes under the category of instrumental errors. Okay, personal error is a determinate error, indeterminate error, accidental error, or none of the above. So you can see that personal errors are somehow the errors that are caused due to not properly careless, or you can say that carelessness of an analyst, he is not performing with the proper attention, proper focus of that particular test that is that analyst is performing. So you can see that these kind of errors can be corrected if the analyst was properly taking care of it. So these kind of errors are also known as determinate errors. These are determinate errors. So A will be the right answer. They are determinate errors. So personal error. These type of errors are exclusively caused due to proper personal mistakes or carelessness of the analyst. Instrumental error. What do you call instrumental errors? So instrumental errors are due to defect in equipment. So if there was not proper marking of the measuring, not proper calibrated apparatus, so these kind of errors arises under instrumental error. Reagent error, the reagent quality was not that much okay, and such kind of faulty reagents, or you can say that not good reagents, causes the reagent errors. Proportional errors are additive type of errors. This type of errors in the magnitude of the error depends upon the sample sizes. Errors in method. So if you are not proper following the methodology, so these kind of errors may cause methodology errors or error in methods. Now next question, non-systemic errors is also known as. So non-systemic error, are they determinate error, indeterminate, accidental, or none of the above? So when we are talking about non-systemic errors, so these kind of errors comes under indeterminate error. They are indeterminate errors. So B will be the right answer. B will be the right answer. Determinate errors are that can be corrected, that can have been corrected. But indeterminate are, these errors are also known as non-systemic or accidental errors. Cause of a random error may or may not be known. Their causes may not be known. So these kind of errors are indeterminate error. Now next question, error is a difference between the true result and error is the difference between true error and measured result, given result, standard result, or all of them. So true value and measured value, the difference between true and the measured value, this gives us the error. So A will be the right answer. Error is the difference between the true result, accepted true result, and measured result. That the reaction, if you are performing and you are having a unit, or you can say that result that is not correct with the true numbers or the true value, these are some things that causes error. Error arises due to the individual analyst is responsible for them. Personal error, random error, instrumental error, or proportional error. So that error that is caused by the individual analyst responsibility, this is personal error and it can have been corrected. So this is personal error. They are personal error due to not proper attention, carelessness of the analyst. These kind of errors arises. All are sources of impurities except, all of them are sources of impurities except, so materials employed in manufacture, methods or the process used in the manufacture, storage conditions or proper weighing. So materials employed in the manufacture can causes the impurity. Okay, so this is correct. Method or the process used in the manufacturing, yes, of course. If you are not following the proper manufacturing guidelines, proper manufacturing processes, so this can causes or impurities. Storage conditions, yes, of course. So if you are not having proper storage conditions, it can also make your compound not good, not suitable for the, and thus causes impurities. So proper weighing is not any condition that can cause the impurities. So proper weighing is not something that causes impurity in your compound. Sources of impurities are materials employed in the manufacture, methods used in the manufacturing of that compounds, chemical process of plant materials employed in the processes, storage condition, one of the important thing, it causes decomposition of the compound. Turbidity produced in the limit test of a chloride is due to, so turbidity produced in the limit test is due to AgCl, BaCl2, AgNO3 or thioglycolate complex. So turbidity produced, and this turbidity is produced due to formation of AgCl, that is silver chloride. A will be the right answer. Limit test for chloride is based on the chemical reaction between silver nitrate and dilute HNO3, that is nitric acid, and thus AgCl is produced, that gives a turbidity, or you can say opalescence. Limit test for heavy metals is carried out to identify and control impurities. Mercury, bismuth, cadmium, all of them. So are they all a category of heavy metals? Yes, of course. Mercury falls under heavy metals, bismuth, cadmium, molybdenum. These all are heavy metal categories. So all will be the right answer. The limit test for heavy metal is based on the reaction of metallic impurities, and what you prepare the standard solution for the limit test of heavy metals is prepared via lead nitrate solutions. Lead nitrate solution, and as per Indian Pharmacopoeia IP, as per IP, the maximum limit for heavy metals is 20 ppm, but for the case of arsenic, that is not more than 2 ppm. The limit test value for arsenic is not more than 2 ppm. In limit test of sulfate, which of the following used to prevent the supersaturation? To prevent supersaturation, what do we use in the case of limit test of sulfate? Is it potassium sulfate, barium sulfate, alcohol, or none? So, to prevent this supersaturation, we use alcohols. We use alcohols, and this alcohol is responsible for the supersaturation, to prevent the supersaturation of this limit test method. So, C will be the right answer. Sulfate reacts with barium chloride reagent in presence of HCl and gives barium sulfate as the precipitate. Barium sulfate as the precipitate, and this is responsible for the turbidity in that compound. The usual limit for heavy metal as IP is, heavy metal as per IP is 10, 20, 30, 20, 40. So it is 20 ppm. For the heavy metals, it is 20 ppm. Okay, for the heavy metal it is 20 ppm. Heavy metals are like mercury, lead, bismuth, arsenic, antimony, tin, cadmium, silver, copper, and molybdenums. In limit test for iron, interference of other metal cations is removed by. So in case of iron limit test, the interference of metal cations is generally removed by using thioglycolic acid. No, this thioglycolic acid is actually converting Fe3 plus ions into Fe2 plus ions. So this is responsible for the reaction, or you can say colored complex formations. Citric acid, both A and B, ammonia. So ammonia generally produces alkaline medium only, no reaction at all. But this ammonia can react with this Fe2 plus ion to form ammonium ferrous hydroxide, and thus this citric acid we use to prevent this reaction. So citric acid will be the right answer. Citric acid will be the right answer. Okay, right answer. We have seen this expression so many times. So let's move to the next question. What is the limit test of arsenic in pharmaceutical as indicated by IP? Limit test of arsenic, is it less than 2 ppm, less than 30 ppm, less than 50 ppm, 15 ppm, or more than 35 ppm? So it is NMT 2 ppm, not more than 2 ppm. So it must be less than 2 ppm, 2 parts per million. 2 parts per million. So IP prescribes the limit test for the presence of arsenic as NMT 2 ppm as an impurity in various pharmaceutical substances, or you can say various pharmaceutical preparations. Nitric acid is used in the limit test of nitric acid, that is HNO3, is used in the limit test for chloride, iron, arsenic, or lead. So we have seen this many times, like chloride uses this nitric acid. Chloride uses this nitric acid as a dilute nitric acid, dilute form, in diluted form, and this reacts with AgNO3 to produce AgCl. So A will be the right answer. A will be the right answer. The closeness of two or more measurements to each other is known as. Closeness of two or more measurements. So let's suppose you have done an experiment and you are having a value of, let's suppose, 70, and then you again perform that experiment and you got a result of 70.1, and again you perform that value and you got reaction like 60, you got results like 69.9. So you are very much close. You are each time close to your value. So this is known as robustness, ruggedness, accuracy, or precision. So you are very precise. You are very precise. You are having the same kind of result each time. So you are precise. So this are example for precision. This is precision. D will be the right answer. D will be the right answer. This closeness of two or more measurements to each other is known as the precision of a substance. The precision of an analytical method is the degree of agreement among individual test result when the method is applied repeatedly to multiply some sampling of a homogeneous sample. Limit test for iron, purple color is due to the formation of. In the case of limit test of iron, you can see that there was a formation of a purple color complex. purple colored complex. It was due to the formation of ferrous sulfate, thioglycolate, ferric glycolate or ferrous thioglycolate. So thioglycolic acid converts ferric ion into ferrous ion, and that ferrous ion reacts with that thioglycolic acid to produce a ferrous thioglycolate complex that was actually having a purple color. And this colored complex is responsible for the limit test, this ferrous thioglycolate complex. We check the standard, we compare the standard with our test sample, and thus this color comparison gives us the limit test values. Error due to weight or loss in weight is which type of error? So if you are having a loss in weight or gain in weight, this kind of error goes under additive error, methodology error, proportional error or constant error. So this comes under the additive error category. This comes under additive error category. So A will be the right answer. So look, it has been observed that an additive error are independent of the quantum of the substances. I guess this is not, we consider the quantity, okay? The quantity of the substance actually present in the essay. Example, error caused due to weight, loss in weight, crucible in which precipitate is incinerated. Detection of this error is ascertained by taking samples of different weights. Okay, so they are the questions that we have seen in our today's video. I hope you enjoyed them. Soon we will be waiting with another of the questions with some new topics and new informations. Thank you all.